Have you ever rubbed a balloon on your hair and watched it stick to the wall? It's a simple and fun experiment that many of us have tried at some point in our lives. The balloon, after being rubbed, seems to magically cling to the wall, defying gravity. That's static electricity at work. This invisible force can make your hair stand on end and create tiny sparks that you can sometimes even feel. It's a force of nature that humans have observed for thousands of years. From the crackling of a lightning storm to the mysterious glow of certain stones, electricity has always been a part of our world. Around 600 BC, a Greek philosopher named Thales of Miletus noticed something strange. He was one of the first to document an early encounter with electricity.
When I rubbed amber, a type of fossilized tree resin with fur, it attracted small objects like feathers. This was a curious phenomenon that caught my attention.
This simple observation marked the beginning of our fascination with electricity. It was a small but significant step in the long journey to understand this mysterious force. Thales didn't have an explanation for this phenomenon. He was puzzled and intrigued by what he saw. He thought amber might have a soul. This idea, though incorrect, showed the depth of his curiosity and his desire to understand the world around him. But his observations sparked curiosity that would echo through the ages. Scholars and scientists would continue to explore and question the nature of electricity. Little did he know he had stumbled upon one of the fundamental forces of the universe. His simple experiment with amber and fur was the beginning of a quest that would span centuries. The quest to understand electricity had begun. From the early observations of Thales to the groundbreaking discoveries of modern scientists, our journey to unravel the mysteries of electricity continues to this day. Each discovery builds on the last, bringing us closer to fully understanding this powerful force that shapes our world. Fast forward to the 16th century, and meet William Gilbert, an English physician and scientist. Gilbert was fascinated by the same forces that intrigued Thales centuries earlier. He conducted extensive experiments with amber and other materials like glass and sulfur. I discovered that many substances, not just amber, could attract objects when rubbed. Gilbert realized that this force was different from magnetism, even though they seemed similar. He coined the term electricus to describe this attractive force derived from the Greek word for amber, electron. This marked a pivotal moment. Electricity was no longer a mysterious property of amber, but a distinct phenomenon worthy of scientific study. Benjamin Franklin, a renowned American inventor and statesman, took our understanding of electricity a giant leap forward in the 18th century. Most people know him for his famous kite experiment, but his contributions to the field go far beyond that single event. Franklin was among the first to propose that lightning was a form of electricity.
In my legendary experiment, I flew a kite during a thunderstorm. The kite had a key attached to its string, and when lightning flashed, a spark jumped from the key to my hand.
This dangerous but groundbreaking experiment proved his theory. Lightning was indeed electricity, a powerful natural phenomenon that could be harnessed. Up until the late 18th century, scientists could only study static electricity. They observed phenomena like sparks and shocks, but their understanding was limited to these fleeting and unpredictable events. The nature of electricity remained a mystery, and its potential was largely untapped. Then came Alessandro Volta, an Italian physicist who revolutionized the field. Volta's curiosity and innovative thinking led him to explore beyond the known boundaries of static electricity. He was determined to find a way to generate a steady and reliable source of electric current. Volta was intrigued by Luigi Galvani's experiments, which showed that frog legs twitched when touched by two different metals. Galvani believed this was due to animal electricity inherent in the frog's tissues. However, Volta had a different hypothesis.
I believed that the frog legs were simply conductors and that the electricity was generated by the metals. This led me to question the true source of the electric current observed in Galvani's experiments.
To prove his theory, Volta created the first electric battery in 1800. This invention marked a significant departure from the study of static electricity, as it provided a continuous and stable source of electric current. He stacked alternating discs of zinc and copper, carefully arranging them to maximize the electrical potential between the two metals. These discs were separated by cloth soaked in salt water, which acted as an electrolyte to facilitate the flow of electric charge. This arrangement, known as a Voltaic pile, produced a continuous flow of electricity. Volta's invention was groundbreaking. It demonstrated that electricity could be generated chemically and sustained over time, unlike the brief bursts of static electricity. It provided scientists with a reliable source of electric current, paving the way for countless discoveries and inventions. The Voltaic pile became the foundation for future developments in electrical science, leading to innovations that would transform society. From powering early telegraphs to lighting up cities, Volta's breakthrough had far-reaching implications, ushering in a new era of technological advancement. The 19th century witnessed remarkable advancements in our understanding of electricity and magnetism, largely thanks to the brilliant mind of Michael Faraday. Faraday, a British scientist with a humble background, made groundbreaking discoveries that laid the foundation for modern electrical technology. He dedicated his life to unraveling the mysteries of electricity and magnetism. Faraday's most significant contribution was his discovery of electromagnetic induction. He found that moving a magnet near a wire could induce an electric current in the wire. This discovery formed the basis for electric generators and transformers, devices that are essential for generating and distributing electricity on a large scale. The late 19th century saw a battle of currents, a rivalry between two brilliant inventors, Thomas Edison and Nikola Tesla. Edison, a staunch advocate for direct current, or DC, had illuminated the world with his incandescent light bulb. However, DC had limitations, particularly in transmitting power over long distances. Tesla, a Serbian-American inventor and engineer, championed alternating current, or AC. AC could be easily stepped up or down in voltage, making it more efficient for long-distance transmission. The war of the currents, as it came to be known, was fierce. Ultimately, Tesla's AC system prevailed, becoming the standard for power distribution worldwide. Today, we generate electricity using a variety of methods, each with its own advantages and disadvantages. Most power plants rely on electromagnetic induction, the principle discovered by Faraday. They use turbines to spin powerful magnets within coils of wire, generating electricity. These turbines can be powered by various sources. Fossil fuels like coal, oil, and natural gas are still major sources of electricity generation. However, concerns about climate change and air pollution have led to a growing emphasis on renewable energy sources. Solar power harnesses the sun's energy using photovoltaic cells, while wind power converts wind energy into electricity using turbines. From the simple rubbing of amber, which ancient civilizations discovered could generate static electricity, to the complex power grids that energize our world today, the evolution of electricity has been nothing short of extraordinary. The journey of electricity has been marked by curiosity, innovation, and a relentless pursuit of knowledge. Early pioneers like Benjamin Franklin and Nikola Tesla paved the way for modern electrical systems, transforming the way we live, work, and connect with each other. As we face the challenges of climate change and resource depletion, the urgency to shift towards sustainable energy sources has never been greater. The environmental impact of traditional fossil fuels is evident in the deforestation, melting glaciers, and rising sea levels we witness today. The future of electricity lies in renewable energy sources. Solar panels harness the power of the sun, wind turbines capture the kinetic energy of the wind, and hydroelectric dams utilize the force of flowing water to generate electricity. Solar, wind, hydro, and geothermal power offer clean and sustainable alternatives to fossil fuels. These renewable sources are abundant, inexhaustible, and have a minimal environmental footprint compared to traditional energy sources. Geothermal power taps into the Earth's internal heat, providing a reliable and consistent energy source. Wind farms, often located in rural or offshore areas, generate electricity without emitting greenhouse gases. Hydroelectric power stations convert the energy of flowing water into electricity, contributing to a diverse and resilient energy grid. The transition to a renewable energy future requires continued investment in research and development. Engineers and scientists are constantly innovating to improve the efficiency and affordability of renewable technologies. Breakthroughs in energy storage, smart grids, and sustainable materials are crucial for a successful transition, as well as a global commitment to reducing our carbon footprint. International cooperation and policy frameworks are essential to drive the adoption of renewable energy. Grassroots movements and community initiatives also play a vital role in raising awareness and advocating for sustainable practices. By embracing these technologies and promoting energy efficiency, we can significantly reduce our dependence on fossil fuels. Energy-efficient buildings, smart home systems, and electric vehicles are just a few examples of how we can integrate renewable energy into our daily lives. We can ensure a brighter and more sustainable future for generations to come. By making conscious choices today, we can create a world where clean energy powers our homes, communities, and economies, ensuring a healthy planet for our children and grandchildren.